Oh, what a pain in the butt. What a pain in the butt. All right. Hello, people. Yep. Yep, 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 yep. Yep, 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 yep. Okay. Do the right thing, TN Spikely. Okay. If bits is greater than or equal to, no, steps is greater than or equal to bits, then also, well, we'll get to it in a minute. Steps is greater than or equal to bits. So what does my do it here do? Okay. What a pain in the butt. Okay. If it's signed, else. Okay. Result. Terp, literal value. Let's just put this up here. Turn true, is that what we do? Ugh. Okay. So, if it's not signed, the result is just always going to be 0. Let's just do this. Leave it 0. Set integer value and type value if is less than 0, value is -1. So we're just taking care of this thing where CPUs don't like to do the right thing on shift in constant expression evaluation. Now, also, if steps. What happens? What happens if we do? Well, let's just compile and test the thing that we just did before we get antsy. NF. NF. We'll put our NF up here. All right. NF. So that still didn't work. We're not setting the, oh, we are setting the substitution. Well, okay, what is this? This goes down here. Well, okay, since this didn't work, we'll do the less than 0 check. Because I think if we go over here and do minus 33, it won't complain. Nope. Nope. Okay, if steps is less than 0, we report error at op cannot perform bitwise shift or rotate by a negative number of bits. It's kind of, I mean, shouldn't you though? It's just, I don't want to have to deal with that in, like doing it here, like flipping the shift direction or just letting it mod out would be fine here. Doing that at runtime probably has a cost. So we're just gonna make it illegal for now, and we'll reconsider that later. Okay. So we're going to do that. There we go. We could actually put the number instead of the operator as the highlight. There we go. Let's make sure this doesn't fire incorrectly or correctly on any of our things. Game compiled. No, that's not the when I compile in 1 second here, that's our own backend. If I do LLVM backend, it's like several seconds. It's like 3 seconds. So it costs you almost 2 extra seconds to use the LLVM backend. How slow is LLVM backend if you tell it to do minimal optimizations? That is the minimal optimizations that you just saw. It is not 0 optimizations because it turns out if you tell it to do absolutely 0 optimizations, then it's even slower because there's just a lot more Bytecode instructions it has to deal with, I guess. So you run a minimal number of optimizations to like massively cut down on the number of Bytecode instructions. And then it's a little faster. Would the shift work with a negative number if you first casted it to an unsigned int? So here's the thing, yes. Look, it would work. But this is constant expression evaluation that we're doing right now. So we don't care a huge amount about performance. Like we of course want things to compile fast, but the percentage of compilation that this would take is small. So an extra like bitwise operation like that is no big deal. The problem is just you want the semantics of your constant evaluation to be 100% consistent with your runtime semantics for something like a bit shift. So then you'd be saying, well, you're allowed to shift things by negative amounts at runtime. And at runtime, you don't know what the number is. So every time you generate machine code for a bit shift, you would have to do whatever you need to do to make that correct. Now, that might not be that much more, or it might actually be the same amount of code. I'm not sure. And so it might be worth doing, but because I'm not sure, we're not going to do it right now. And we're just saying it's illegal. And then if we want to make it legal later, we can like look at that. How come my backend is that much faster? It's a long story. I mean, LLVM is a very general tool written for a lot of people with a lot of different concerns, and that kind of thing is always going to be slower. I don't think it should be as much slower as it is. I think it's also just the people who make that kind of system don't know how to make code really fast. That is what it is. It sounds bad because it's compiler authors, but it's true. Like every modern compiler is really slow almost. It's because not even most compiler programmers, but most programmers today did not learn in a culture of where it actually I don't know how to say it, where it actually really mattered to a stark degree whether your program is fast or slow. Like in games, if your program is slow, it's basically failure, like nobody will play it, right? In compilers, if your thing is slow, people just sit there for 3 times as long as they should or whatever, right? So, and then especially if all other compilers that you're competing with are also getting slower over time, then it doesn't feel like you're really slow, right? And so you end up in this situation where all these programmers, well, okay, and then while what they're doing is getting slower and slower, they're all talking to each other and convincing each other that what they're doing is fast. They're all talking about all these zero-cost abstractions that they use to keep their code fast and whatever. And so because they think they're being fast, they don't entertain even the idea that they're actually very slow until someone comes along and shows them how slow they are, right? Which is one of the many points of this project. You work with a custom build of UE4 and the compilation waiting drives me insane. I worked on an Unreal Engine project in 2002. And it took 45 minutes to compile. Even if you changed like an Unreal script variable, because the Unreal script variables, you know, there was a thing that would like compile those into a header file that the C++ code could read. And that header was like global. So it would do a full rebuild. It takes hours now. Well, I guess it got worse. Is it possible some of the slowness comes from the flexibility? Yeah, I said that at the beginning. Like for sure, if you have to make something more flexible, it probably is slower. That's just a rule. So part of it they can't help, but most of it they can help. By wall clock time, most of what the slowdown that they're incurring is avoidable. Would you live stream on YouTube someday? Maybe. I mean, I just live stream here because it's set up and I don't have to think about it. And I just hit the button and go. Like YouTube, I would have to go figure out. And honestly, I am not a big fan of YouTube's content censoring policy now. So I kind of don't want to support them. Okay. Well, so I got to figure out why this other thing didn't work. It seems simple enough. Oh, this is the wrong type. That's the type that I want. All right. That would be a good reason for it not to work. I kind of want to clean, whoops. All right, let's go back to release build. Okay, that worked. How about if it's signed? That worked. How about if it's -7 signed? That's not right because that should be 0, right? This should be if it's signed and what are our things? Shift right. Bytecode bin up bitwise shift right. I don't remember what the field is. Okay, so if it's a right shift and it's a negative input, blah, blah, blah. So op is, what is it called? Sometimes operator type. Wait. That's not going to be the bytecode. That's going to be the... All right. It's going to be this other one. It's going to be this. Okay. That was a hassle. There, it's 0. But if we shift right, it's -1. Okay, that's good. Now we have to do this at runtime, except not yet, because the problem is this function has to also handle right and left rotate, which we added yesterday, and it doesn't. So if we do this, it's going to say 0, I think, because we did add the part where we call this function last night, yeah. But what we didn't do is this. All right. Wow, this is a lot of, let's just see if what we can do here. This just looks like a big mess for nothing. Like, what is all this? It just seems like more. Okay. Okay, this is not even used, so get that out of here. We'll grab the two literals. We're going to just make this work more in a mentally understandable way. Okay. Do I even use this for real? Let me see. So we make a result. We get the number of steps. See, this is already... This is just like the curse. We're still not handling this correctly. Because even though it's stupid, this could, in theory, be like a 64-bit value that's so big the high bit is set. I'm going to defer that till later. And then we would treat it as negative. I don't know. Just like having signed and unsigned types is kind of a curse, honestly. It's really kind of not good. I'm just not sure if the alternatives are better. right? So the deal is this integer value is signed 64-bit. So, and this is a constant, right, out of the program. So we don't exactly care about all the things we would care about runtime, about how many bytes it is and stuff. So if it's like a negative signed 8-bit or whatever, we just, you know, it's sign extended, it's fine. But if it's a U64 with the most significant bit set, we're going to think it's negative and we're going to reject it. I do have an item on my to-do list that generally involves sanity of this thing anyway, and so I guess we'll deal with that when the time comes. I'm going to defer it for now, but future discussion on unsigned stuff. Maybe he didn't seem that motivated to do another big discussion last time I talked to him, and I kind of understand why. So, yeah. Yeah. Okay. So what were we doing? We were cleaning this up, so it makes more sense. You know, the number flags we don't use up here, right? The number flags we use down here, so we'll put them down there. Okay, so this is less of a mess. It still looks like a lot, but like, okay, we're getting literals. It's just, we don't appear to use this. Okay, let's see how bad we broke it. Oh, I did use number flags. Oh, yeah. All right. I lied. So here's the annoying thing. The reason why I wanted to factor this around is we're calling this for shift and rotate operations right now, and it doesn't understand rotate yet. But the reason we're calling it for shift and rotate is like all this is the same. And honestly, the checking for number of steps is going to be the same. So like everything down to there is the same for shift and rotate. But all this is different. And so I'm just going to put this in an if statement. Which is super ugly. Okay. These are the shift operators. Rotate operators are in the else clause. Okay. Else. And we're going to do an assert down here. We're going to assert that if we got here, our op is a rotate operator. Okay, rotation, it is valid to do it by more than the word size. Okay. So if we get to the rotate operators, then we say, actually, this can be out here. We're doing this trick that we talked about yesterday about getting a mask from the bits -1. And then we can do this evaluation. Okay. Now, okay, we just yesterday implemented this in C++ in here. And what I'm wondering is, why do we have separate code for these two things? So this is what I think we're going to do. I think, okay, we're going to do this in several steps. We're going to check in because we're going to do massive, scary changes to the code that we want to revert. Before we check in, we have to make these things not constant expression evaluate for a bit, because it'll be wrong and we don't want to, well, nobody's using these yet, so it's fine. We'll just let it be incorrect. We'll check in with this. Okay, before we check in, we'll retest, because we just did a bunch of stuff to the code. So we'll retest a few of these cases. Maybe we'll start actually building a little test case that we will check in later, right? To test these things. And we'll retest this. Once this works, okay, see all this do it thing here? This is some stuff that I wrote for constant expression evaluation that's doing all this stuff. Okay? This is basically the same as this. It's just like different. And the problem is this part, this compile time execution part, is not checking the number of bits like we're doing like down here. And we really want this to be the same code probably. Or we want to duplicate it over, I don't know. Maybe we just put an if statement here. The reason why I'm thinking about sharing the code is that this is more non-trivial. Yeah, so I think we should share the code instead of having two implementations. Did I find myself modeling LLVM API a bit with my own backend? God, no. No. No, 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 no. Our backend looks nothing like LLVM. I hate that API. It's terrible. No, 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 no. No, 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 no. No, 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 no. No, C API is not that bad. Okay, here on stream, way back years ago, when I started thinking about doing the LLVM backend, people advised me do not use the C API because it doesn't work that well. That might have been incorrect advice. It might have been only correct at that time, but we are using the C++ API for that reason. Do we have any fuzz testing? Yeah, we do. We definitely need to expand its capabilities, but we have a basic fuzzer. Do I think it's possible to add something like bit fields in a way that doesn't suck? It would be really convenient to have a bitstream pointer, cast it to a struct, and access the member data without doing a whole lot of bitwise operations. C has issues, can't guarantee the memory layout. I just don't like, I never want to do bit fields. I don't understand why people care about bit fields. Honestly. Like, just set the bits. Set the bits to the things you want. If you were doing that all the time for all your data types, I could see it. I would be like, yeah, that's a pain in the butt. But like, you don't almost never do it for anything. You definitely could do a metaprogramming thing that does bitfield kind of thing. You wouldn't have to build it into the compiler. I'm just like, why? Will you specify the alignment structure types? Yeah, you already can do that. Glad you enjoy the witness. Glad you enjoy the witness. Okay. Let's go back and make sure I didn't break things. Okay. Let's start making it more like a test. Just of bitwise ops so far. Make that an odd number. All right, well, interesting. Why are we not asserting on these shifts? I would expect these to be wrong. Oh, because these are all constant expressions. Of course they're not wrong. They are not going through the backends at all because they're constant. Okay, so we're going to put this in a section called constant shifts. We're going to have a section called non-constant shifts. That's going to be empty so far because we're not expecting this to work yet. Yeah, we won't. We're basically just going to paste all of this and just make these from constant into non-constant, which is easy. And we take out the assert is constants. Okay. Now, we don't appear to have broken this. Let's just build the game. Make sure that still runs. We'll run the tests. Is there a platform-specific integer type? No. No, there is not. You don't need to specify a size. You can say int, but int is defined to be signed 64-bit. So, all right, great. So we're going to check this in. Oh, let's put in the changelog so we don't forget to report to our fine beta testers. Okay, Schfit. All right, we're starting to get some changes in here. At some point, it'll be enough to justify sending out a new beta. Let's close our Discord and our Steam. All right, so. Yeah, we're going to check in. Okay. So now, do I do the ugly thing now? Yes, I do. So yesterday, these shift operations are in this doit macro. And we're gonna break these out into their own other things. So we're gonna go there, right? Okay. Something like that. And we're going to have a doit shifts. And that's just going to have these two things. Okay, wait, that's for the switch. That's for the macro. Emacs. You're a hopeless cause. Okay. We're going to have a doit shifts, and we're going to have a doit rotates. And they're just all going to be the same. That's probably not right. Does it even compile? Wait, what? So we have our doit. Okay, right. So this is very silly because I was putting all this macro definition in the middle of a function anyway, because I was only using it locally to the function. Let's not do that. Now, this is the actual function. This is this stuff. Now I still have like an extra brace here somewhere. And I don't think Emacs is really going to help me with it because it's modern software. 182. I mean, it says this one. Okay, wait, but this one is obviously for that. So this one should be for this. Like, how is that even debatable? Oh, because there's no backslash. Macros are the best in C++. Steps undeclared identifier. Wait, that's in the... Wait, what? Didn't I compile and test this after making this? Okay, we're on red alert because I just checked in something that like wasn't the source code corresponding to the executable I was running. It's probably fine. Actually, I think all I did, right, was paste this from down here to up here. But it was saved, so people are going to be getting a compile error till I check this in. Let's just check in this one file. Oops. Fix an editing mistake. All right. We are not going to check in the file that we're doing the massive surgery on. which is this one. And that, by the way, is bad. I get annoyed whenever people do partial check-ins because it's the #1 way to break the build is to forget to check something in because you're doing a partial check-in. But the build was already broken, so oops. All right, so now we have our do it shifts and our do it rotates. And okay, the reason we're doing that is because we don't want those to be in this do it, because we don't want them to be in run math bin op. Okay. We're going to do this. We're breaking them out into a separate path. Any idea why GPU vendors don't promote ISA-based GPU designs to be more like CPUs? There's probably a lot of reasons. One is they genuinely don't feel like they could do as good of a job at being a GPU, which I disagree with, but they think that. Secondly, if you're trying to sell something like a GPU, your whole deal is that your platform is proprietary. So it's like it's valuable that people have to buy into your stuff, especially, well, okay, it's different. The dynamics are different if you're the market leader versus not, okay? If you're NVIDIA, you're the market leader, and so you want people to have to buy into your platform because that'll introduce friction that'll keep them from moving off of your platform, right? Now that screws up the environment for everybody else and creates pollution, tons and tons and tons of pollution, but that's your incentive if you're NVIDIA. If you're AMD, I mean, you're not, like, you're still a significant player, but you can't afford to require people to do a bunch of stuff to do your thing. You're more likely to want to be compatible, but see, the thing is, introducing an ISA is like such a radical departure that it's actually negative, because then it's like, oh, people don't want to have to do all this weird stuff to do your platform, right? I mean, that's how it looks like to me. Like, the thing is, it would have to be the market leader to do that, and the market leader isn't incented to do that. Doesn't AMD document its ISA now? Well, I mean, okay, having an ISA, so like having instructions that the chip actually runs is different from having a long-term stable instruction interface that you vow to maintain backward compatibility on, right? Which is what your CPU does. So your CPU, like the CPU in this computer, it's got an ISA that you interface with, and those are nothing like the instructions it's actually running. It's translating those instructions into the real instructions all the time, right? And it's just, they've maintained compatibility for decades of that interface. Sometimes a little too much, I'm of the opinion. And so I don't believe that AMD does that. Maybe they do. I haven't heard of that if they do that. Do I have any theoretical basis for the nature of the language or language design choices made mostly pragmatically? There's videos on YouTube about that. You can go watch. There's a playlist called Programming Language for Games where you can see all of the thought process, including the early thought process, which wasn't as good as where we are today. How do you learn about parts of your code that are UB? Well, Clang has a thing called UB-SAN that'll look for UB. It can't really tell you because I don't think it can really tell you 100% of UB, but it could probably get a lot of it. What about a talk about language stuff that did not work out? I'm just busy. It's not that interesting of a topic to me. Like most of the things that we ended up not doing, we didn't really not do for an interesting reason. It just, they weren't that good. I would rather talk about the things that are good than talk about the things that weren't that good. It's just more important. ARM and MIPS have broken backwards compatibility. I don't know anything about ARM. This is an Intel CPU, right? So that's specifically what I meant. I mean, nobody uses MIPS, so like, whatever. And MIPS lock themselves into that really weird situation with like the single branch delay slot. It's like, okay, that was a good idea for 1 or 2 processor generations, and then what are you going to do? And then you just got a weird instruction set, right? So, even with that ISA, it basically does include configurations and all that's needed to even set up the GPU, that the GPU accepts a stream of instructions. Yeah, I mean, that's the thing is like, I'm actually not sure because I haven't looked at these AMD drivers or how they work. But yeah, like for some reason, people who make GPUs think that you should fill out 5 years of tax forms in triplicate to be able to start doing things on the GPU. And it's like, that's not how your CPU works. Your CPU starts running instructions, bro. Like, it's just what it does. How do you approach writing x64 backend? First make compiler generate assembly code. I did not do assembly code. A lot of compilers work by generating assembly and then assembling the assembly. That to me seemed like an unnecessary step that makes things more complicated than we would like. So we output machine code directly. And the first step is to have something that you want to turn into machine code and to know what the machine code instructions would be. And then you just write the bytes out for the machine code. It's like not, you know, you could write assembly text representation if you want to read through and debug it and make sure it's right, but it never seemed useful to me. I mean, I can go look with a debugger at the assembly code that I generate and make sure it's right, and that converts it to a string. So like, why go to a string in the middle? You're just burning CPU cycles. How much money on average does a game engine developer make? If you mean it like a AAA studio, I don't know actual salaries, but they're pretty good. They're not as much money as those people would make working for a crappy company like Facebook, but they're good. Like, they're definitely in the well over $100,000 range. So like, I mean, top people probably make 300 to 500. Like the person for a large AAA project who runs the engine development makes good money, right? And then there's a question of like what's salary and like what's profit sharing and what's options or whatever, and how it gets complicated. Compilers seem to be full of unnecessary steps. Yes, they are. They are full of unnecessary steps, top men. All the configurations for their little PC GPU is already 6 PDFs to about 60,000 pages. What? That's crazy. I'm not surprised, but that's crazy. How are the compile times holding up? They're good. From 0 to 100, how much is the language done? Negative 73 plus 47i plus 22j plus epsilon k. Why are you using macros here? Because the problem is we need to do the same code for 8 different types. For 8, 16, 32, and 64-bit numbers for signed and unsigned. And that's a giant pain. In C++. How do you decide if a construct should be added to the language? I mean, it's design, right? You say, how useful is this? Like to what extent does it solve an actual problem as opposed to just being a cosmetic bauble? Like a lot of people who are designing new programming languages, including some popular languages, like add features based on really surface things. Like, oh, this makes a certain expression shorter or whatever. And it's like, okay, but that's not the problem I have as a programmer in the year 2020. The problem that I have is that I drown in complexity and trying to write bigger programs. And so if your features aren't geared toward bigger programs, they're probably not helping, right? So there's that kind of consideration. There is the consideration of like, how well defined is this? Do I know what this does in all cases? How does it interact with other features? Is it going to be hard to make it work with other features, right? All that kind of thing. Okay. Let's get back to doing this. So we're breaking out our shifts. And let's look at what run math binop did. Oh, it's also operating on bool. I don't think we want to do that. I mean, we don't have to because bool is not an acceptable argument. It's just this was being called for all sorts of stuff, including like Boolean and floats, and it's a little too general. Okay, but basically, this is the reason why it's a macro, is because we do a little bit of setup, and then we just use these macros over and over for the different types. See? See? Oh, you know what? If we break this out, we don't need our type unsigned. For the regular doits, right? Because we added this last night, this argument in doit integer. That was just for rotates. So like we can take it out. Okay. Now, let us okay, what is this setup that we're doing, and what of it do we actually need to do? It's not legal to shift a pointer, so we don't have to worry about this. Okay, we're just going to make a run shift op right? And run rotate up. And theirs are going to be the same. Let's call it bin op, just to be very, very, very. Okay, wait, what was this? We don't need to ask about check index B because that's for if it's unary or not. So we're just doing this. This is just a debugging thing where we just make sure that we're not about to operate on corrupted data. This just helps me debug when things get really crazy, which doesn't happen often, but once in a while, you're really glad you did this. Okay, so we're going to do this, and then we don't have to worry about any of this, but we do worry about this. So run shift bin up. This is really going to add to our lines of code. Not that bad because, so we get rid of do it. Oh, is there a way to shorten this? I kind of don't think so. All right, but these aren't do it integer. These are do it shifts. Okay, and then let's get rid of the type unsigned here. Actually, but not. Whoops, I'm getting lost. So this is a rotate bin op. Okay, and these shifts are rotates, and that is the one that needs the type unsigned. Okay, but this one doesn't. So we're deleting this thing we did yesterday. Okay. Boom. Let's go to our do it integer. Let's get rid of this. Bam, 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 bam. Sometimes programming is like you do a thing and then you undo the thing, you know? Okay. Great. So because this is C++, this won't compile until we go here and do these things. Whoops. Okay. Oh, and then this. Ho-de-do-de-do. Okay. We run shift bin up, we run rotate bin up. We just added some lines of code right there. We added 59. Ugh. Ugh. No, we're over 50,000. Oh, except, wait. I might have some junk files getting counted. I mean, that's what happens. Sometimes you have to add lines of code. We've been under 50,000 for so long. I've been scraping under. Blank lines doesn't matter. This is without blank lines. This is actual code lines. No T today. No, I need T. How are we ever going to get back under 50,000 if I don't have T? Okay. So we're doing this. We're doing that. And like we should just test some things. Okay, well the game. Oh wait, we didn't rebuild the compiler, right? Oh, we did. Really? Gotta juke the stats. Juking the stats. All right. All right, well, we'll run these. I forget, what was in that test that we just did last night that had like some... We had a rotate test last night. Should be printing some things here. Oh, but none of that is running at compile time execution. I'm sure some of all the compile time execution we did to organize this will have had shifts. But we still should test it for a minute anyway, just to make sure we didn't totally host things. Okay, so provided we didn't totally host things, I'm going to check this in as an intermediate step of like having factored these things out of run math bin op. That's a useful thing. And then the next step is to try and reuse this do it shifts and do it rotates. Right? We want to try to reuse these between the compile time execution and the constant evaluation. You think the rotate left case from last night could miss some cases because it's only wrapping zero? What do you mean it's only wrapping zeros? I don't understand. Where's rotate left? What do you mean by only wrapping zeros? In the test. In the test. Bits is 4. What do you mean by only wrapping zeros? That's not true. Most of these are, right? So Cafe Babe is 32 bits. So for the 64 bits, there's going to be zeros, right? But for 32 bits, there's no zeros. For 16 bits, there's no zeros. And for 8 bits, there's no zeros, right? The test tests all those sizes. That's what we're doing. That's what we're doing here, right? 8 bits, 16, 32, 64. Does that address your concern? Okay. Cool. Cool. All right, let's do a little bit more. We're going to have non-constant shifts here. And well, I mean, the problem is most of these are out of range, and like that's not supposed to work yet. We haven't done that part yet. And part of what we're doing here is to do that part by combining them. So I'm just going to comment this out for now. Well, okay, let's do the, let's actually do, so that we don't forget later. But then, so those are not constant, but they're now commented out. And we're going to say, just going to throw in some dummy examples. A is 5, A left shift equals 3, B is A left shift 6, A left shift is 3, assert B is equal to A, print B is whatever, or like that's really stupid. And then we'll just do some stuff here. This is dumb. We're just being dumb. Right shifting by 3. Right shifting by. Let's put some braces. Braces. Okay. AIDS food face. Okay. And then we're going to say, we're running main at compile time still, so that's fine. Oh, we don't have left, left equal and right. We didn't do those operators in this language. In my attempt to just cut down on the number of operators. So this is my C++ habits coming out. All right. Well, we died in... This looks like a mistake that I just made in the refactor because it's hard to imagine what I would have done. Line 70. Oh no. Sorry, this was an assertion. Okay. Line 74. Assert B equals A. Really? Let's print it first. Like, am I stupid or did we mess something up? A is 320. Oh, because, dude, you got to do these things in the right order for them to be equal. Like, what am I even talking about? Okay. Great. Shouldn't the B assignment happen above first A shift? Why, yes, it should. Yes, it should. Okay, we have tested a little bit, some stuff. It sure seems to work. So we're gonna check that in. So, why did we do that? Because, wow, hold on. My throat is funny today. Corona? I don't think so. I think I have like a very, very mild, it's just enough to make my throat a little bit funny. Chai is calling me. I think some hot tea. I think some hot tea is calling me. Earlier today, I wanted a band for and blah, blah, blah. Look. Okay. I'm not even going to read that. I get what you're saying, though. All right. I really have not been outside. In order to be sane, I've been going outside for about an hour every 3 days, maybe more than an hour some days, but like not around people, you know. And yesterday was one of those days, so it's quite possible that I could have caught something, but we'll see. If I die, then at least we started refactoring the shift operators before that happened. High pollen count? I don't tend to have like allergies. My blood oxygenation is still 98%, which is fine for when I program. Like, I tend to hold my breath sometimes when I'm programming, so it's fine. All right, so the tea water is going to heat up. I'm going to make a pot of tea, and then we're going to factor these things into their own header file so I can include them in both places. Do I have I decided that the coronavirus was serious at the end of January. Remember when there were news reports about like, hey, China's building all these hospitals and like in Wuhan, they're welding people into their buildings. That all happened in January, right? And like, for some reason, nobody here was like, oh, this might be serious. Instead, everybody was like, oh, let's look at what's happening in China, right? So I bought stuff. I bought like serious, like non-paper masks. I have like, you know, masks that you wear if you work in paint fumes all day. And I have a blood oxygenation measurement thing. I have a closet full of MREs. Like it didn't get bad enough to need the MREs, but it could have. Right. I mean, that's the thing is like, how did anyone think that all that could be happening in China? And even in January, we knew this virus has like a long incubation period during which people are asymptomatic. And you're like, the only reasonable conclusion at that point was the virus is already spreading everywhere, just in small amounts. And like nobody was willing to jump to that. But like if you had a brain, what's my favorite tea? I don't know, maybe Bengal spice. It depends. So Ebola did not spread. Yeah, that's because it's not really asymptomatic for that long, and it's also not as contagious. They didn't lock down travel. Yeah, for sure. I mean, you had to do a bunch of stuff. Even in January, you would have had to have locked down travel, but then also people would have already been here spreading it just in small amounts. So then you have to figure out what to do about that. Can we have an MRE review stream, Steve 1989 style? There's no way I'm going to do as good of MRE reviews as Steve does. So you know, Steve is doing his thing. Are MREs better than regular non-perishable food like cans and a bunch of staple food like rice? Not necessarily. The thing is, I mean, how bad are things going to get, right? That you don't know that in January. Like now it seems like, okay, things are not going to get that bad. Although here's the thing, right? This is the thing, like disaster preparedness is about being ready for something that might happen, but that you think is not even necessarily going to happen, or preparing for things where you don't know what's going to happen, right? So here's the thing. Disaster preparedness is not about preparing for the coronavirus because it's already here. You already know what that is. Disaster preparedness now is for like, what if a disaster happens, right? So like, what if there's a big earthquake? Like usual disaster preparedness. What if there's a big earthquake? What if there's another virus that happens like next week while we were already dealing with this one, right? What if there's an earthquake and the water supply in San Francisco is really damaged, and because supply chains are messed up from coronavirus, it's hard to repair things, like whatever, right? That seems like being paranoid, but only to people who are not used to thinking about these things. Like, you got to remember, San Francisco completely burned to the ground 100 years ago. Like, it was bad. The whole city was gone. And so you have to at least consider those things. And so, yeah, so why do I have MREs in the closet? Well, I've got canned food also. I haven't eaten the MREs. I have eaten the canned food, right? The MREs are for like, well, what if electricity goes out, right? What if I can't stream? What if the water supply? Well, the MREs aren't going to help you that much if you don't have water, but like, what if you can't heat water because the stove doesn't work anymore, right? So that kind of a thing. What if aliens attack? Well, I mean, what if they do? I don't know, dude. That could happen. Does it rain much in San Francisco? San Francisco is weird. It goes through some years where it's very, very rainy, and then other years where it's not that rainy. Like recently, it has not rained very much here. But I remember years, I mean, maybe this is climate change. I don't know, but there were some years around, let's say around 2000, 2001, 99, 98, where like it was very, very heavy rains frequently for months. Used to snow in Moscow too, but not much anymore. Yeah, I don't know. Maybe it's climate change. All right. Key. Okay. We're on Singapore breakfast tea, which it's not good if it oversteeps. So we've got a few minutes. Okay. Would I consider creating educational material? I mean, I kind of don't have that much time right now. In the future, maybe, but I sort of thinking about educational material in the form of a game or something. I don't know. Do we support CUDA integrations? Like, look, it's just like anything. You call out to the functions and you can do the functions. It's fine. Like, anything that you would do just by calling a function in a library, you can do. That's like one of the basic things, like any language. That's one of the things they get up and running early is foreign function interface. And then you're fine. Do threads have a bounded stack size? Well, I think right now we grow them indefinitely. I'm not actually sure. Actually, no, that's not true. I mean, this depends a little bit on backend, right? Because with the LLVM backend, we're just doing whatever LLVM does right now. For x64 backend, I actually don't think we expand the stack at all. So I think you run with whatever stack size you get in the beginning. I don't know. It's a thing that hasn't mattered that much. We might put more thought into it later. All right. Sorry, a lot of these questions that are happening right now are the same questions I get all the time, and I just can't. If I spend time answering the same questions I get all the time, then we never get any work done. Okay. Why not make frequently asked questions? I should do that. I just don't. Because that takes time too, and there's always other things to do. Yeah, a lot of these questions seem very troll questions, so it's another reason why I'm not inclined to answer them. And that's the funny thing is you can't tell. Like, some of them seem like very troll questions, but they're also questions that some people would legitimately ask. And so I don't know what to do about that. Okay. Okay. What we are doing now, we're going to factor these macros out so we can use them. And then once we can use them, then we'll make this one incorporate the check for the number of steps that we did in the other frickin' place. Okay, so we're going to cut this. We're going to put this in a file called shift and rotate macros, right? And we're going to include that here. We're not going to forget to add this to source control. And then we're also going to include this in bytecode runner. No, in the CPP. And then, oh wait. Oh, in constexpert.cpp, sorry. Okay. These macros are used in two places. In bytecode, let's get rid of this, runner.cpp for compile time execution, and in constexpert.cpp for constant expression evaluation. Now it's an open question, like why am I not doing this for everything? For like plus and all that. And the answer is maybe I should, but I think in most cases it's not worth factoring out because behavior of plus is like not really problematic. Although maybe we should detect overflow. I don't know, man. Maybe we'll end up factoring all the math out this way. But in the long term, we've been saying we actually don't want compile time execution to run interpreted the way it does today. So, yeah, I don't know. Okay. I don't know. You know what? You know what I need? I need a little bit of... No, I don't. We'll see. I might want to put a little honey in my tea today. That might happen. Okay, so this should just compile. And provided that it does, we're just gonna check that in because that's just a little discrete change. We're just gonna say commit factor macros into a header file. Shift rotate macros. Bam. Bam. Okay. Next. we got to use them. But before we use them, we don't want to regress in functionality. We don't want to regress in functionality. So here in constexpr, we just did this thing where we did this checking. So we have our own do it macro here. We had this checking for number of steps and all that. And well, this is complicated now that we're trying to combine these things. Because here we're pretending that B is the same type. Oh no. We're going to have to change these macros a little bit before we can use them. Because this is just reading straight. Ugh. All right. No, this is terrible. This is a disaster. The reason this is a disaster is that the part that we want to share is just this tiny part down here. Like this is different between the two cases, and this is, so I didn't think about this enough. Now, down here, by the time we get to this, it's actually more stuff. And actually, since we only call this for rotates now, we can actually factor okay, you know what? We could actually factor this quite differently. Because most of the lines here are in common, and we can factor them up because we don't have to worry about other things besides rotates now. And then the question is, well, we still need to be a macro, unfortunately. Let's just start doing some things. So this, and this definitely very easily go up here, right? Okay, so that's good. Then this, let's change the switch. Right to that, else we're going to assert that this is the other thing. Okay. So now that we've done that, well, we can certainly factor off the bottom. That saves us some code. Okay. And then, of course, this if can be factored out, right? So if our shift is 0, or if our rotate amount is 0, it doesn't matter if it's rotate right or rotate left, right? So what we want to do is this code transformation here, where that goes on the inside. Like that. That's better. That's really a lot better. And that's, you know, it's just funny that that's the kind of thing that could happen. All right. Also, Emacs, nope. I was going to say it got less confused, but it got confused right there. Okay. Trying to get all my slashes in the same place. So I just spilled tea on myself. That wasn't good. Time to hot swap the clothing. Number of shifts 2. What do you mean? I mean, we could do, this can be factored out. Right? We can say counter shift here. This is the counter shift. And then we call this counter shift. Right? That's a lot better than what we had. We have an extra brace here for some reason now. Delete the auto right shift thing. Oh, this thing, yeah. Whoops. Whoops. Like, really, that's so much better than what we had. Okay. Next thing I'm going to do is I'm going to put the instruction here. And so then we can translate in our const expert, we can just pass these in. Right? And so when we do this, when we call do it rotates, let's call it inst, or yeah, it's not that good. Okay. So, I mean, really, I should pass A and B in as well. We'll look at shifts in a little bit, but Do I need... So I definitely need type unsigned down here. I don't need it up here. All right. So it's really messy. This number flags, is this coming from out here, right? You could pass it to the macro, but at some point it just gets crazy and you just, whatever. It's a macro, use it for macro things. In fact, instead of passing all this stuff, I'm just gonna embrace the macro. If you're using macros, use macros, you know, that's what I say. So the things that are parameters here are the things that are not actual values. Values are going to be defined, right? Okay, and then instruction number flags, A, B, R. All right. See, this is so annoying. Because this part, I kind of don't want to make this 3 lines per thing, but I kind of need to. So it's like prep, do the thing, and then store. And the reason those have to be separate is because this thing wants that subscript, right? But so in C, macros correctly expand to macros, right? So I could go like, I could do this, right? And I could say, I mean, this is when you start going to the second circle of hell here, right? But right, so we could do this and this stuff, and then do it rotates. I think this works, right? It's been so, I used to do macros in C all the time, and I have stayed away from it except in emergency circumstances because they have so many negative properties. And what's happening now is like, there's definitely memory of things that don't work recursively, but I don't think it's macro substitution. I think it's like string concatenation doesn't work recursively or something like that. Something weird like that. Like if you use the hash string concatenation? I don't frickin' remember anymore because I've purged my brain of those things. So we call do it rotates, and then we do this stuff. Right? We get A, we get B. Actually, we're going to want to change this B eventually, but whatever. We call do it rotates. This expects A, B, and R to be there. And then we store R. So it'd be easier with a simple templated function. Maybe, except it can't really be a template because, see this part here? So these types you maybe could do in a template. This is not a type. This is like a member variable of a struct. Maybe you can do that with templates. I don't know how. I stay away from templates all the time. Now, instead of using this member variable, I guess we could like cast to a pointer to the thing. That's not exactly well defined, but we actually might be able to get away with that. So in principle, we could make this a template function. I mean, I'm sure if we were willing to make it a 17-page super ugly template function, we could do it in a different way somehow, but do you think the space between brdo rotates and parenthesis will make everything die? That is quite possible. I mean, who even knows, right? Okay, so we're doing this, and then now what happens with macros is you do all this stuff and it doesn't work, and you get syntax errors, but you can't tell where they are. That's the awesome thing. Oh my God, it's compiling. All right, cool. One problem with macros is they directly substitute parameters. So you have foo a b is a times b, and you evaluate 5 plus 2. You get 5 plus 2 times 4 or not. You have to put parentheses around all. Yes, that is definitely, if you're doing macros that take general expressions, you should be super paranoid and put parentheses around everything. In this case, we're not doing that because we're not actually taking any expressions. We're just taking like types and member names. But yes, that it is very easy to be sad when you're putting macros together. In before segfault, let's see. We built release build. Boom. I have a return statement in one of the do it rotates. Yeah, okay, here's the thing. This one is fine. This is actually what we used to do, and I kept it there because we wanted that. It's just, it doesn't actually matter here. So I guess we might as well take it out. It used to matter in the old context where this came from. Here it doesn't do anything because fall through, it's empty at the bottom and not fall through. But I think it's, for long-term code maintenance, it's confusing to have this here. Like this will cause an ugly surprise at some point. So we shouldn't have it. Okay. So I think the next step is use this macro in constant expression evaluation, and then check that in once that's worked and tested, and then we can attack the shifts. Because for the shifts, we have two different versions of the code, and that's not good. What is subscript with a capital S? Subscript with a capital S. There's no subscript with a capital S. It's a lowercase s. What are you talking about? Think you can move the auto counter shift line into the else block? Oh, yeah. Yeah. Good point. This can go here. Massive time win. No, not really a massive time win. But certainly understandability of the code is improved whenever you do that. Right? It's like, these are the things we need here. This is the thing we need here. That's good. Now I can remove subscript from do it rotates. Yes, good point. I had thought of that before, and then I forgot. Yes. Oh, this, right? This is what you meant. Yeah, well, that was a mistake, but it doesn't matter because we never use it, right? And so with macros, if you never use it, it doesn't exist. Which is a problem with macros, actually. Okay, now I understand what you were saying about the capital S. Okay. Let's go to Constexper. All that constant folding will be very nice. No, okay, so this is a constant confusion that people have. If you're talking about what I'm doing here, you have to have, well, if your language is going to be powerful, you have to have constant expression evaluation early in compilation before you get to stuff like 3-address code and bytecode generation. Because there's just certain classes of things where it matters if something is constant or not. Like if you declare an array with a certain dimension, right? If you wait until your code generation does a bunch of constant folding and then you're like, oh, this dimension is constant, it's still too late. You generated different code for that than you would have otherwise, if you even support dynamic array dimensions, right? There's lots of cases like that. In this language, because, like if you're going to do the equivalent of a C++ template where you have an integer argument to your thing, that has to be known at compile time, right? Well, what kinds of expressions are allowed to generate that number? Well, it depends on what your constant expression evaluation looks like. Yeah, but I don't exactly know what the conversation in chat was about. That's just why I am doing this. That is an explanation of why we are doing what we are doing right now. Okay. So now what? Well, we have a big hole in our heart down here, right? So we want to use our do it rotates macro, and we want to like copy this. Okay, this down here. Do we allow you to shift a pointer? Hold on. I don't even remember what my policy decision was on this. Nope. Okay. So because we don't allow you to shift a pointer, this here, I probably did this before I made this decision. So we're just going to assert this. Wait, what did I just delete? Hold on. Yeah, why did... oh yeah, that. Okay. We're just asserting this, and we're not going to if that. Okay? So then we're going to copy this. Copy that. Control. Okay. Rotate operators. Bam. How did we structure that? I feel like this is factored the other way. See, here we did unsigned versus signed on the outside. I'm going to convert this to this because I like this better. So unsigned else. Okay. And then inside we go 64-bit. 32-bit, 16-bit. This should just be else. Let's do this. And that might actually lead to a few fewer instructions being generated in cases that almost nothing will ever exercise, but it's fine. Okay, so here, 64, 32, 16, else, okay? And then doubled up, whoops, bam. And then, we're gonna make a thing called CE do rotates. And we don't need a subscript, I don't think. Whoops. Except those are the argument names. Those aren't like... Okay. So we need to make these things. Whoops. Okay. So U64, U32, U16, U8, S64, S32, S16, S8. All right. Wait, we could use, instead of doing subscript, we could use the hash operator here. The reason we couldn't do that before, okay, we're gonna do so many cleanups. We couldn't do that before because there were some subscripts that had different naming, but for these integer types that we're dealing with here, that is not true. Okay, so we're going to see do rotates of U64. I mean, I almost want to do this a little different. Let's try this. Right? And then here, size, comma, size, comma, is, or signed char, right? We're going to go do some things and then call do it rotates with the type this is questionable what I'm about to do, but signed char, is it double hash for concatenate? Single hash for stringify? I don't freaking remember. Size, comma, u size. Right, so we're generating the type unsigned and then closing. This is really gross and stupid. Hash is token pasting, right? And so when this expands, it'll make the token first and then call the macro, right? It won't call the macro with this as the argument and then expand it later. I don't think that matters either way, but it's a thing to be nervous about, right? But why? Because it's less, see here we have a lot of redundancy in these arguments, and here we don't, right? You know, there were like a couple years in college, maybe a couple years is too much, but like 18 months in college when I decided that I was going to use the M4 macro preprocessor instead of this crappy one. And that was kind of fun, but you had to run it explicitly from your make file as a prepass on everything, and I just don't have the patience for that anymore. And M4 seems really cool, but it is also really not strongly typed in some ways that are bad. So why don't I have another macro for the if-else stuff on sign and size? Maybe we'll factor it out that at some point it becomes impossible to understand, right? Like this, at least, you know, once you get to 3 levels of macro, I don't know, right? Okay, so what do we want to do here? We need an A, a B, and an R, right? So we're just going to say A and R have to be defined in CE rotates. Because they need to vary based on size. Okay, so A is the argument, which is, I mean, we can look and do it, for example. That's just what this value is. This seems a little bit sketched the way I was doing it, but okay. Auto value, we're going to put the type here because it's in parens. You know, do it rotates could use decal type, right? Like instead of passing, let's consider this for a second. Instead of passing the type here, wait, we don't use type anymore. Bro. Okay. We don't use type anymore. We just use type unsigned. Okay. That's great. So we do it rotates. This is A in the parlance of this macro that we're calling. And we need an R. So we're going to say auto just to stay away from, that's how this works, right? This is, decal type is so bad. I think I just do that, right? So this will compile. This won't actually, well, let's do the result storing part, I guess. Oh, no, this is result. R. Okay, something like that. There might be some type problem happening here that's going to annoy us, but whatever. Okay, now do it rotates doesn't need type, right? Which means here, this doesn't need type. Okay, how many mistakes did we make? 1 million. NF. Oh, we never, I pasted this. This is number flags. Okay, and remember we said number flags had to be defined in the outside over here we need instruction in number flags, and we haven't done those. Okay, so and then well, let's be lazy about this one. Get binop from token. Okay, so these are optional. This is stupid because it's just one value or the other value. And I could just put that here, but I'm just going to call this function because I'm feeling like a modern programmer now. Okay, get binop from token. Oh, well, now I'm no longer feeling like a modern programmer. All right, so if Operator type is token rotate right. Instruction equals this, else instruction equals this, right? Okay. Great. I don't need type in do it rotates, but doesn't my comments say that using type unsigned is incorrect? Yes, but that's a different issue. So we need type unsigned no matter what down here. This is what this is really for. Okay. This thing about mask. We'll change this in a bit. Actually, no, we'll do it now. This could be decal type B mask. So we just want the type to match B, but we need type unsigned for these. All we're trying to do here is say don't, like this is really goofy. All we're trying to do is say don't sign extend this shift if it's a negative number. And we only need this in half our cases, right? Because half of them are unsigned anyway. So whatever. Oh. It's like sometimes C is like Lisp and you need more parentheses. You just need more parentheses. Where is B? B is required to be defined by whoever calls this macro. So like here, it's here. All right, do we run? Does it blend? Does it blend? It blends, at least partially. All right, so wow, I drank my tea already. Let's start heating up some more. Now here's the thing. Macros are really ugly, but I understand them easily, and people on chat can follow along who have been exposed to these macros because they're just not hard to understand. If you start doing like modern template metaprogramming to do the equivalent of this, you're going to have an ununderstandable disaster very quickly. It's going to get nuts very fast, and that's not fun for me, and that's not fun for people on the stream. Imagine sitting down and just working. Yeah, I know. If only more people today would do such a thing. Okay, so this is good. This is great. Now we are going to see if this actually works. So the whole point of this is to constant evaluate shift operations, which is a thing that we have not yet had the capability to do. So let's go back to this, and we're going to have constant rotates Okay, we're going to have constant rotates and non-constant rotates. Non-constant shifts are still not going to work. That's a whole separate task. that we might do later today. Okay, so constant rotates is what we're testing. And non-constant rotates I don't actually know what the answers are for these. I mean, I could figure out some of them, like that's x, right? B is equal to x. We're just going to have to print what these things are. Okay, rotates, rotates, rotates. And we don't have non-constant rotates yet. Did I ever see the macro to allow to count the variadic argument count of a function? I don't even want to try to understand this right now. Is this something about I don't know. That's using some weird side effect of macro evaluation or something. Okay. So we have our constant rotates here, and I mean, how do we know if it's right? So this seems right because this is the same as rotate right by 1. So first of all, the is constant is asserting, right? Like if I change this to not is constant, we die, right? So this is good. This means our constant expression evaluation is invoking, which is great. How hard do we want to work to try to make sure that these are the right answers? Because like I can go assert what they are right now, but how do we know that this is right? Whoops. Like I could just be asserting that we freeze it at the wrong answer. Seems right though. We could just check it against the runtime values, right? So we pretty much trust our runtimes. So this was all compile time values. These are runtime values, right? So -4, -7, which is the same as the input number, -49153, 939 and 999, 14, the F is 7, which is Y, yeah. So that seems good. So we win. That is a victory for us. Yesterday in 2 hours, we implemented these operators for runtime, and then now we have done the constant evaluation. Okay. So let me check this in, and then we'll just go back. So the next step is to combine the shift handling. Let us commit this const expert evaluation for rotate operators. Operator. Operator, okay. Great. I got to see if my tea is steeped the right amount. Not yet. It's a little watery. Give it a little more time. Why I'm not using a library like Intel XED to encode and decode x86 instructions. First of all, I don't want the dependency on someone else's library, especially because I want this to run on any platform. I want to be able to cross-compile from, I want to be able to run this compiler on a Raspberry Pi and build a Windows executable in the long term, right? And the more weird dependencies you put in the way, the further you get from that, all right? Second, I think they're going to be way slower than whatever I would write. I don't have empirical proof of that, but I sure feel like that's true. That said, I haven't looked into it, right? If it's a full source library and very simple and very fast, then maybe I should consider using it, right? But most things are not that way. Is it a good idea to compile expressions into bytecode for their compile time evaluation so that both expressions and functions use the same interpreter? What do you mean by expressions? Do you mean the constant evaluation that we're doing right now? All of this constant evaluation that we're doing right now, we could do via bytecode execution. The thing is, bytecode execution is really slow. Like, you don't want to invoke it every time somebody says +1. Like, constant +1 happens a lot, right? For example, you just don't want to run a bytecode execution engine every time that happens. That's like some modern programmer bull crap if you do that. You want constant expression evaluation to be very fast because you want your compile time to be very fast. But I'm not sure if that was exactly your question. Oh, tea steeped. Let's assume it's good now. I mean, it's the second steeping, and it's interesting how different teas, even though this is kind of a mostly black tea, its second steeping is a little weaker than like an English breakfast or whatever. This is the Singapore breakfast tea. It's all right. XED definitely isn't simple, yeah. I mean, it's because x86 encoding isn't either. That is true too. I don't know. I mean, so the other answer is just right now, we're just not serious about instruction selection, like at all, right? And we won't be for a while because the next step about instructions in the back end is to actually try to reuse registers instead of pulling everything from memory all the time and writing it back to memory all the time. So that doesn't even involve instruction encoding. Like, our current instruction encoding is fine for that. We just need to like understand that we already have something in a register. And then, wait, Insobot has a tea timer now? That's good. That's a good feature. You can't create fields? Yeah, you can. Oh, not at runtime, yeah. Right, that is correct. You could never get down with second steepings. Second steepings are really good for some kind of teas. So at this tea house, which I don't know how to speak Czech, but Dobrá čajovna, or however you would say it. Awesome tea house. They have a couple in the US, but this one I went to in Prague. They're all about like 7 steepings of everything or whatever. You go in there and you get your nice glass teapot on a candle that keeps the water hot, and you just get some tea and you're just hanging out for a couple hours and you just keep pouring the tea. Yeah, it means good tea house. Yes. That place is great. That's my favorite place to get tea. And the one in Prague, there's multiple in Prague, but the one that I went to in Prague is like, it's better than the American ones a little bit, even though it's like the same teaching. I don't know. They just do it a little bit better there, even though they don't speak English there and I don't speak Czech. It's just a little bit better. Like they use the glass teapots there, and in the US they use teapots like I have, like a stainless steel thermos thing, and it's not the same. It's not the same. I prefer the Czech way. Okay, we did const expr rotate operations. I can check that off my listy list here. You can use XED without the library because they publish detailed instruction tables and data files. You could generate your entire encoder by parsing their data files. Yeah, I don't know about that. I mean, maybe eventually. So the thing is, in the short term, we don't actually use that many instructions in our backend. So it's not that bad to just do it yourself. In the long term, I would have to look at that and evaluate how unhappy that would make me as a human being to do that in order to judge. I often use auto in C++. Do I find any inconvenience because of missing type names? No. And in fact, in the actual programming language we're making here, we use type inference all over the place, and it's honestly not an issue. Like, I never get confused about not knowing what type something is. And then if you were to, like modern IDEs or whatever will tell you that anyway. So it's really not, like I used to when I was first doing C++ in the late 90s, I was like all about writing types everywhere because I thought that I really needed that, but you don't. You don't need it. How is writing GUI code? Well, we do our own in the game, our own little immediate mode GUI library that just does what we want. We do have function bindings for DRM GUI as well. Yeah. Have you ever had to deal with RSI? Once in a while, I start getting wrist weirdness, and actually really more so the tendons up here start feeling weird. And then I put on wrist braces, or usually it's a problem with the sitting height. So if I adjust the height of my desk or the height of my chair to get it right, it usually solves that. But like I can generate a little bit of pain very quickly if I go to like a Starbucks that has incorrect table height and just work there for one day. It'll cause problems for me easily. So I just notice those things and take them seriously when they happen, and they never get bad. Is type inference ever used for other things than convenience? Yeah, so if you're going to write a generic function, like what we call polymorphic functions in this language, you kind of can't say the types of things everywhere, because the whole point of the function is it applies to things of different types, right? So type inference helps you a great deal there because you're not writing out types all the time. And so the function is able to apply to more things. What am I missing in DRM GUI that I wrote my own immediate mode GUI? Well, I just don't like taking dependencies on stuff if I don't need them. And part of, well, and this engine dates way back to, Dear MGUI didn't exist when I started writing this code, okay? Because this was the editor for a project called Happy Cake that I did in like 2003 to 2004, okay? Dear MGUI wasn't a thing, right? And then that got used in Braid, then that got used in The Witness, and then that got used in the new game. So like this code goes way back. Way back. Do we have lambdas? No. We do have, well, we have anonymous procedures. We don't have anonymous procedures that automatically capture data at this time. Why is it the software companies increasingly seem to not care about performance? I need to give a whole talk about this. Part of it is the economic structure is that they don't need to care. Part of it is that programmers honestly don't know. Programmers these days, almost none of them honestly know how slow their code is because it seems not that slow because everything else is slow around them. And the way that human beings understand things is by experience, right? So your feeling of how fast a computer should be is just by how fast you see it performing tasks from day to day. That's how fast your computer should be. If it takes 2 seconds to pop up a window all the time, that's just how slow computers are, right? And so unless you really study and look at the numbers and know how many operations your computer can do in those 2 seconds and what the hell is it doing for all that time, it seems reasonable. That's why. Do I think immediate mode GUI is appropriate for actual desktop application? Yes. Is the compiler as fast or faster than back then? It's probably about as fast. Like it speeds up because we do things to speed things up, but then it slows down sometimes because I change the way the core system works and just don't then go do the optimizations. So like I took out most of the dependency system, but part of the way that dependency system worked was making things go to sleep instead of polling all the time to see if they're ready to compile. So we probably have an excess of polling right now to see if things are ready to compile, and that costs us some time. But the good news is that's relatively easy to optimize back out, and it just hasn't been done. You're wondering if I agree or not that games are not so optimized for multi-core systems. Well, console games are definitely optimized for multi-core systems. Well, non-Unity console games. So console games where people write their own engines are optimized for multi-core effectively. But that gets harder and harder to do as there are more and more cores. And it takes a great deal of engineering effort. It's just a hard problem. Actually making code parallel is a hard problem, and people have not come to grips with how hard that is. However, use DLL hot loading, not totally. No. All right, let's get back to programming. So now if we go into our constant expression evaluator, first let's factor it. Let's factor it. Okay, to be the other way around. We're going to go whoops. I did full replace instead of query replace. We only want to replace these. So we're calling do it. Let's, instead of do it, wait, which one's, this is the old one. Okay. So now this is in the same format as this, where it's signed or unsigned outside and then size inside. Now, like there's all kinds of things we have to do because our shift macro isn't ready to be used either. But we're going to make one here called CE do shifts, actually. And that's going to be here. And we're going to take the same arguments. Did I check in? I did, didn't I? Yeah. Just making sure. Okay, so if we write shift, okay, we need, instead of type, we go signed char size. Let's do the same. We did auto. Auto value is this. And then, let's just put braces here because we're being consistent. Okay. This is all going to change. We're just getting it ready to interface with the other macro that we factored out. Making sure we didn't screw that up. Let's actually run our test. Okay, constant shifts still work. That's good. Yeah, the GameCube used cartridges still, right? I wish modern consoles would use cartridges. Maybe it won't matter with PS5 and how fast it loads things. Like maybe with SSDs, we're getting to the point where they're almost cartridge speed. It used mini disc? Oh. Was it N64 used cartridges? And the handhelds use cartridges. Like the current Nintendo console uses cartridges, right? Or am I tripping? Yeah. The Switch does. I never liked optical discs as a medium to deliver games because they're slow. They're cheap, but they're slow. First night free after 2 months of Corona childcare. Oh no, that must have not been fun. I mean, having kids at all is a lot of work, but like having kids sick with a deadly disease that is sweeping the world is like, that's gotta be not a good time. Modern cartridge would contain a download like you are and still stuck with 60 gigabyte download. Oh, you mean like a thing that just downloads the game? Yeah. Or, I mean, you would have to deal with patches coming down. I think the problems that we had in previous console generations about patches being the full size of the game, I think that's mostly going to be fixed in next gen. We'll see. Okay. CE do shifts. It's a lot like PC load letter. Okay, so we have this do it shifts, and our problem is this stuff all has to change to be like this. And then we have to get the code that was down here about checking sizes and put that in the frickin', like, in this, and then move this over here. Like, whatever. Let's start doing the steps. So bytecode runner for shifts, we're going to want to br do shifts, right? But we don't need type unsigned. That was for the other thing only. Br do shifts is going to go this stuff. Well, let's do all this. This is basically the same. Do it shifts, stomp, done. In fact, if we're feeling spicy, we can refactor this to take shifts or rotates as a parameter. Let's get this working. I almost don't want to do that. Ugh. I mean, no, well, we would have to pass type unsigned, even though it's not used to br do shifts. We don't, that's just a step too far, right? Okay, because this actually is this, or do it shifts. Yeah, this will make more sense. This currently has these arguments, but okay, this part is factored out. And then we're going to switch on instruction. Okay. Where is run shift bin up? Okay. We're going to put this down here. We're going to take this part about the instruction and put that up here, just the same, so we can use that variable. Now, we do it shifts. We take this. Why? Oh, Emacs, you're bad. What is it even doing? Like, this is the whole thing about computers, is stuff that kind of works and then totally fails for no, we're just going to leave this indented like this. Whatever. Our backslashes are in chaos. Okay, so this stuff, we're going to take out the return, and we're going to take out the stomp and this, because that's here. So like this macro, literally at this point, looks incredibly stupid. But that's fine, because it's going to get less stupid. Let's take out the switch, because that's what's confusing Emacs. Like, why is it putting it that it's lining it up with the define? What is happening? Okay. I don't know why it wants to put it there. I guess this is something that somebody decided on. That looks really stupid to me, but okay. Anyway. Okay, so this is really a lot of macro to just do this. And the point is, we're not going to just do that. But let's make sure it compiles, which it doesn't. Too many arguments for function-like macro invocation of do it shifts. Okay, we knew that because we want br do shifts down here. First of all. Secondly, we changed our format to take now I'm getting confused again. Okay, it was in the other file where we did the character and the size differently. We might do that here because it was pretty successful, but here we take the type and the subscript still. So that, there we go. Okay. Great. Great. Let's run this. They still work. Non-constant shifts, those are running in this thing that we just did. So that's good. Now we want to do have some non-constant shifts. These shifts that we did are pretty mellow. They're by a small number of bits, right? We want to do shifts by a number of bits that are beyond the word size, but we don't want to assert on the answers yet because our backends are not going to handle that yet. But we at least want to print them and see if they're right or wrong. And then we put that checking into here. So right now, the constant expression evaluation does that checking, but the bytecode runtime does not. So we're going to go here and we're going to leave our stupid ones down here. Here are some mellow ones. Okay. Do the right thing. Okay. So, we're not going to assert these. We're just, I mean, we could assert that one and that one. So these assertions will not run correctly, not even in bytecode evaluation, right? So if we look at our non-constant shifts here, so C is supposed to be 0, for example, because we shifted it by a great deal, but it's like some number because it wrapped. It's not supposed to wrap. Okay, this is x64 specific behavior. It's actually undefined behavior. So right there, we could have potentially had a coup and deposed Donald Trump and turned the United States into a communist country, and we'd be standing in bread lines right now. But fortunately, the compiler decided not to do all that due to that UB. Yeah, it could have created a time machine and gone back in time and replaced Gandhi with evil mustache Gandhi, and then who knows where we would be, right? So we got lucky that that didn't happen right there. Isn't it architecture defined? I don't know. I think it's actually UB. Like Chandler Carruth's lecture at least seemed to indicate. So this is UB almost no matter what. Like this is C++ UB. I don't know if it's LLVM UB, but shifting into the sign bit is C++ UB because C++ does not know if numbers are 2's complement or not. I believe with LLVM you can tell it that numbers are 2's complement. I hope so, but you don't think that's how wrapping works. I'm pretty sure it does. Anyway, okay, so the non-constant shifts. What? I kind of want to open a window. Let me see. What is my weather? It's a little cooler out. Let's open the window. Okay. So we have here this stuff, and we have this checking here. And this looks a little familiar because a little bit of this is a little bit like what happened before. We're just going to move this. All right. So we actually are going to need okay. Outer code instruction. You know what? Let's make it just bits, because this one down here is just using the number flags to get bits. And like, number flags is kind of a complicated concept. And right? Okay. So we don't know this. We want this. Of course, I will regret that if we end up needing to know. Anyway, it's fine. So then in bytecode builder, or no, bytecode runner. Okay. In fact, I like that better than bits from flags. There's two different ways to get the size. Right? Okay. That doesn't rely on the number flags. Let's just make sure all that compiles, because we sure did some things right there. It does not. Bits, undeclared identifier. Oh, because we did it. Yeah. Auto bits wage their battle to destroy the evil forces of the C++ cons. Okay. We have auto bits. Okay. Now Well, does it blend? I'm doing an Elon. How am I doing an Elon? Dude, Elon does way more than me. I do an epsilon Elon. Epsilon times Elon. Elon just invests, I do the actual work. That is not true. Whoever told you that is misinformed. Okay, look, if you guys are going to start bagging on Elon Musk, you can leave this channel. That's all I have to say. You can leave this channel. Because we need people who work hard and do ambitious things. And if you're just going to, you know, this is what's so bad about the internet is like there's certain cultures that people get into and they just have preordained beliefs. And yeah. He's self-destructing today on Twitter. I thought Elon's tweets were fine. Like, has he got new tweets after the Free America and the I think Tesla stock is too high? What's he been saying? I think those are great. Now it could be that this has been hacked, but like I doubt it. Like what's wrong? Like why can't people have opinions? This is the thing about the internet today. Somebody moderately famous has an opinion and everybody's like, "Oh my God, that person's so bad. I am qualified to judge this person because I am so much better than them." And their opinion is wrong. Even opinions like maybe America shouldn't be a fascist state are somehow controversial now. Like, really? He created his own company's stock by 10%. Yeah, that's fine. I mean, a short-term move for something like that doesn't really matter unless you're in a cash crunch. Like the long-term value of saying something like that is actually substantial. Like, look, so Donald Trump, for example, is immune to certain things. There's certain kinds of attacks that would destroy other political candidates, right? That didn't work on him because he's just like, yeah, I'm kind of a slime ball and whatever, you know? And so there's certain avenues by which you just can't attack him because he's not pretending to be certain things, right? So this kind of a thing, if you say, oh yeah, our stock's a little too high or whatever, you're building a persona that makes you immune to certain things. Like people can't come to you in a shareholder meeting and pressure you and say, we need you to make the stock go up and blah, blah, blah. I mean, because you're just like, you know, whatever, man. Like there's tactics to these things that I think people don't understand. That said, if you use a word like charlatan to describe Elon Musk, you are completely detached from reality. The fact that you use the word charlatan is an immediate signal that you got it from an internet forum where other people use the same word, right? First of all. Secondly, the dude is single-handedly responsible for the US being able to launch astronauts into space. You got a problem with that? Like, and we actually can't do it yet, but we're going to be able to do it within like a month. We can't, do you understand this, people? The United States is not capable of putting human beings into space. That is not a thing. I mean, single-handedly, he obviously didn't build all the stuff, but like, if he had not started the company and made it happen, nobody else would have. That's what I mean by that, right? So, like, you have to understand the magnitude of the kinds of things he's gotten done. And a lot of these Elon attacks are from right-wing people. There's a different kind of attack from left-wing people, right? They both hate him. But like, what, do you want America to not be a superpower anymore? Like, what is your deal, right? Why do you hate America? So, I don't know, man. It's just it's very silly. I mean, definitely he makes unrealistic statements sometimes. Definitely his schedules are wildly optimistic sometimes. But he usually does what he says he's going to do. It's just late. So like, if you want to call Elon Musk a charlatan, you have to post your resume and show what you've done that's better than what he's done. So, in my opinion. Seriously, if you're going to be an anti-Elon troll, I may ban you from this chat because, I mean, it's totally reasonable to have opinions. It's totally reasonable to not like him. Whatever, that's fine. But like, the virulent internet, totally unreasonable anti-Elon, everything he does is bad trollishness has no place here because this is a place for reasonable discussion. That's all. You're graduating soon. 90% of jobs are about JavaScript. Yeah. I mean, here's the thing, though. The field of programming is way, way, way bigger than it's ever been. So even though 90% of jobs are JavaScript, in absolute number, there's a lot of jobs that aren't that. It's just probably harder to find them in all the noise, but there's a lot of jobs that are not JavaScript. Okay. Yeah. Like working on like LiDAR and radar and stuff. Like none of these people building, well, almost none of these people building self-driving cars are programming them in JavaScript, thankfully. It might actually be none, but people are so dumb sometimes. Probably at least somebody's doing that and thinks it's good. Also, all these deep learning people, they're not programming in JavaScript. And that's a big trend right now, you know? I mean, some of them might be programming in Python, but, you know, it is what it is. You wonder how much game industry programming is total C++ mess? A significant amount. Like some major engines are big C++ mess. Like Unreal Engine is pretty C++-y. From what I heard, like back when Source 2 was in development, I heard it was just insane, nasty C++ everywhere because the authors of it thought that that was a good idea. I don't know if it's still that way or if they changed it. Okay. Where even were we before we started talking about all this stuff? We are migrating our situation here. So we have shifts, and we're in the constant expression evaluator. And here we go. So our CE do shifts is this old code, right? And so we're going to make this call do it shifts now, right? So this is going to be A, and then steps is going to be B. So CE do shifts, or B equals steps needed for macro, right? And then we're going to set instruction before we go in here, right? So we're going to do A. We're going to do the same thing that we just did here, right? We're going to go do it shifts, set result. Bam. Okay. We don't really need these two parameters because there's only one thing here. For rotates, we actually needed the size separate, but in order to do it, yeah, all right. So I feel like I forgot something. Oh, we need to set instruction. Like here. Yeah. And we change rotate to shift. And then we have our instruction. And that hopefully will work. Except it doesn't because we didn't name it right. Value. Undeclared identifier. Auto A. Right. This is A. Or R. This is R. We actually could define R in here. I kind of don't know why we didn't, but whatever. It's a little bit arbitrary. Okay, so we have our constant shifts. We have our non-constant shifts. It's great. Now note that our non-constant shifts are still wrong, but that's fine because we haven't done the part like this is the non-constant shifts are only running this. The constant shifts are running this after doing this checking. So now what we want to do is move this checking into there. Let's put this comment there. Okay. We're going to say if B is greater than or equal to bits. So here's where here's what we're going to do. We're just going to make it 0 all the time. So we're going to do an if-else. So now left shift, this is always correct. Right shift, it is not. Wow, this is going to turn out to be a lot cleaner looking. So we'll get some of these right, but we won't get the -1 right. Oh, we broke. Oh, because we broke our... See, because our constant evaluation is going here too, and I just said we won't get the -1 right, and now we're asserting that we got the -1 right at compile time. Okay, so we want to know if we're signed or not. And we're just going to let number flags in this case, okay, it's just bits. Because we don't care if we're signed for rotating. Here we care if we're signed. So if b is greater than or equal to bits, oh no, it's right shift. If b is greater than or equal to bits, if number flags and number flag oh no, this isn't right. We need to, okay, so this depends on the value of the source thing. This is where it gets a little... We're going to pray that the optimizer optimizes something out. Or, honestly, maybe this is going to be small enough that we don't try to use the same code. I don't know. Okay. The problem is it's not whether the type is signed that we set it to -1. It's whether the type is signed and the high bit was set. Okay. Here's what we do. If the type is signed, actually, no, guys. All we do is we limit the right shift to 31. Because, look, there's either a 1 bit in the top bit if there's a 1 bit, or not 31, let's say, for example, it's a 32-bit word. If there's a 1 bit in the high, then you arithmetically shift right by 31, and you get all ones. If there's a 0, you shift right by 31, and you get all zeros, right? So, like, that's an interesting trick that I hadn't... Come on, what? Emacs, what is wrong with you? Okay. There we go. And then, so R... Now that doesn't work for unsigned, because for unsigned you won't get a sign extension from the top. Or for unsigned, shifting by word size -1 is just not enough because you'll have garbage in the top bit, right? The thing that makes this work is that whatever was in the last bit is actually what you want in the final answer. Are bit shifts sign extended? They are if your type is signed. Yeah, we don't support assembly yet. We want to eventually, but it's too soon. Okay, we still messed it up. Let's see what we did wrong. It still says -1. It says -4. Did we recompile? No. If you want to succeed in the game industry, compile your compiler before you compile your thing with your compiler. All right. So that's great. So that works now. And that was handy. Plans to write our own linker. No, we will not write our own linker because I don't think a linker is a good idea. I don't think it makes sense. And a lot of our problems right now in programming can be traced to the fact that we use a linker. So no linker. Linker can go jump off a cliff for all I care. Okay. You'll notice not only are our constant shifts correct now, our non-constant shifts are also correct in bytecode. They're not going to be correct in machine code. So if I actually run this was a compile time execution. If I run it at runtime, this will come out right because that's pre-baked into the program, but this will not come out right. All right? So there we go. Constant rotates are correct. The non-constant shifts are not correct. Let me just fill in the non-constant rotates. I mean, we might as well do that for completeness. I thought what just happened there? Okay, I'm so confused. All right, let's try this again. Constant rotates. We're pasting that to non-constant rotates, right? Okay. Assertion failed. What did I mess up? Oh, it is non-constant rotates are not going to be constant. News flash. There we go. News flash. Okay. This is good. Okay, I'm going to take a stream break because it's been a few hours and I could rest for a little bit. We're going to come back in a little while, and when we come back, we're going to make this work. So this part about this not working at runtime is a bummer, right? Because so in C and C++, it is a bummer, not even just that it's not defined by the programming language what happens when you shift, but that on Intel at least, you get an answer that you don't even want, probably. Right? Like shifting actually wrapping is not, that's not a behavior that ever really makes sense to you. So what we're going to do is we're going to add, we're going to change the semantics. Up till now, the semantics of shifting in this language have been just the C semantics, right? We're going to change them so that, well, we already have partially changed them, right, at compile time and constant evaluation, but at runtime, we're also going to change them so that, shifting by more than the word size gives you the predictable result that you would naturally extrapolate if you were an actual human being, right? And it's defined to do that. And however, that involves outputting more machine instructions to check the result. And we will want to, first we want to output those instructions, but then we're also going to want a way for you to say, like, look, I, the programmer, know that this isn't going to wrap, so don't do that, right? Just do the old thing. So we want to do all of that later today, if that makes sense to people. Let's check this in, though. That was successful. That was a good increase in robustness of the compiler. We've reduced duplicated code that does different things. All right, thanks everybody for coming by. Let's see who's still up. Science and tech. Who is doing science and technology? Ugh, I hate that. Okay, who's doing science and technology? Why am I second? I have 623 people, and Lana has 255. That's not fair. That's not fair. It's actually kind of out of order generally. I wonder if Twitch is adding randomization, because look, this is 143. These used to be strictly in order, but now it's randomized a little bit. She does have a few assets I don't. That is, she has a lot of assets that I don't. Let's put it that way. Okay. What looks good here? I don't know. Does anyone see anything that's like jumping out? Is like, oh, that's going to be really cool. There's a recommended versus view count. Recommended for me. Well, okay. Game development using Basic 8. And what is the Basic 8 engine? It's on Steam. An integrated fantasy computer for game, and you can create, share, and play discs in a modern Basic dialect. Okay, I dig it. That's dope. We'll do that. Where was that? Basic 8. All right. Thank you, everybody, for coming by. And see you later.